Right, so today we're doing a JZ Modular harness, and this one is running a Link Fury G4X ECU. So let's get into it. Right, so as discussed, it's a JZ Modular harness. This one in particular is going on a 2JZ GE VVT-i, but it's been turbocharged and has a front-facing intake. It is running a Link Fury G4X ECU, so a complete standalone. And as we discussed, it is a modular harness, so all the different subsections we're going to go through as part of the layout. But first of all, as it's completely newly built, we're just going to cut through to the photos of the building of the harness so you can see the process that it's gone through, and obviously you can see all the small sub-harness sections over there. So let's do that now, and we'll be back in a second. Right, so again, it is a JZ Modular harness. First thing we're going to do is go through the complete layout. We're going to discuss all of those sub-harness sections as part of the JZ Modular harness system. And first of all, we're going to start at the ECU end itself. So nice and simple, two plugs for your ECU. This is your data cable that's plugged into our laptop over there, so we can do all of the things we need to do over there. But nice and simple, two plugs that go into the ECU, really straightforward. They all come into this point over here where we're going to have a few things broken out, so we're just going to go through those with you now in a second. The first two major ones are this section here, which breaks out and goes into the fuse box over there. So those are all the powers and everything for the harness. Remember, the fuse box is controlling all the powers for the harness itself. The other section that breaks out over here goes to there, and that's all the controls from the ECU to the fuse box, so powers to the ECU, etc. as well. All right. Now then, we've got a bunch of little sections coming out here. So what we do like to do is to avoid you guys having to add pins to the existing ECU plugs. Once they're all nicely done, we're adding a whole bunch of stuff in here for you. So I'm going to start from one side and work our way to the other. So the first one is we've got our CAN plug. So hopefully you can see that it is all labeled up there. So it has got power and ground and CAN high, CAN low. So this, now you can use this to plug in a CAN dash or any other CAN device that you would like to do. We then have an auxiliary plug, so it's a 3-pin plug here. So these are some unused pins from the ECU that allow you to easily interface with them. Usually if it's like an analog input that requires a 5-volt and a sensor ground, that is also included in here, which is going to bring me neatly onto the next one, which is the analog spare output. So this has a couple of spare analog inputs, and it'll have 5 volts and sensor ground as well in there. So that's that. So we've got auxiliary, we've got CAN. Right, digital. So this has a bunch of digital, unused digital inputs. Okay, so those you can use there. Okay, so the auxiliary one would be, I think it's 3. It's going to be basically 3 unused auxiliary outputs. So you can use these if you want to control a relay for your cooling fan, etc. And then lastly, we've got a pedal. Now, what we've done with our modular system is we've actually incorporated the ability to use drive-by-wire. So although in this particular case, the customer is not using drive-by-wire, he does have the ability to add drive-by-wire later without having to have a whole new harness made. And he can then connect his pedal up to there. Obviously, the pedal plug will have a 5-volt sensor ground, and it'll have 2 analog voltage inputs for a pedal sensor. So if he didn't want to use a pedal and he didn't want to go to drive-by-wire, he then has another 2 analog inputs here that he can use for something else if he would like to as well. Okay, so those are all the little extra add-on pieces that you have there. Obviously they're inside the vehicle, so they stay away from water, but they are completely sealed up and waterproof on the inside there. Moving along here, we've got about a meter of harness that goes from there all the way to where it joins at the back of the harness. We've got a grommet in the middle. You'll see we haven't shrunk down the heat shrink on here yet. So that's for the customers to then put it in the vehicle, move this grommet to where it's appropriate, and just grab a heat gun and you can heat this down. And that's a glue-lined SCL heat shrink, so it'll completely waterproof the whole harness on the interior side from there. All right. Coming up to the back here, this is where you're going to end up with your harness having your first breakout section over here. So what we're going to do is start off with all the breakouts that come out here. Starting first of all, we've got our injector harness over here. So again, the reason we do this is nice and easy, so you can change all of the injectors. In this particular case, you can actually see the harness, the customer's got different injectors from what you have on a standard 2JZ engine. So you can see we've actually interfaced from his connectors to our injector so we can get the engine started and test and make sure everything works. Next up, we have our map sensor. So in this case, the customer is running a 3-bar map sensor because he is running a turbocharged application. So we do need to go above atmospheric there. So 3 bars should be enough for the customer to have more than enough space to go where he wants to turbocharge. Next up, coming out here, we have got our wideband oxygen sensor. So in this case, we are supplying the customer with a Bosch LSU 4.9 wideband. And as discussed with the Fury, it's got built-in control. So the connector is right there at the back and he can just put it into the exhaust down the section over here. Okay, that's that one. Okay, so the next one is going to be our ignition harness. Now, in this case, we can't fit individual coils underneath this throttle body, unfortunately. So you'll see we've actually made a little tiny sub-harness section to allow us to use an igniter to run these dumb coils. So remember, a Link ECU cannot run dumb coils. So dumb coils, what I mean is they've only got 2 wires, a power and a ground. So the actual ECU itself doesn't have the hardware capable of running those dumb coils. So you would always need to use an igniter. In this particular case, the customer is actually using Audi coils. So you can see there is his ignition harness already built with his 6 Audi coil plugs ready to go on there. So when he puts it in, he's got a front-facing intake. He's going to have all the Audi coils over there. So just for our testing purposes, so we can get it to run, obviously we've made this little interface harness so we can use the igniter to fire the dumb coils. But again, it is a complete sub harness, so if the customer wanted to change to R35, Denso or whatever, not a problem. He can just phone us up, we'll make another sub harness for whatever coils they desire. And anybody else looking for something like this, it means you can choose whatever coils you want for that. Okay, so that's it. And then on this one there is a ground that runs underneath there just to be bolted onto the block over here, just supplying the grounds for the coils and everything is required over there. Right, so that's it. So we've got wideband, we've got our ignition, and we've got our injectors, and we've got our map sensor over there. So moving along here, we then have another breakout over here. So hopefully you can see that down there. Sorry, it is a bit hard to see with all the inlet manifold in the way. But in this breakout over here, we've got our cam sensor. So you can see the cam sensor down inside there. Well, hopefully you can. Let me just try and pull it out of the way. There it is. There's the plug for the cam sensor over there. Okay, so that's that little section over there, and then you have a ground, so you can see it's bolted to the inlet manifold there. So coming out here, you've just got those 2 sections, which is going to be your cam and your ground, so that'll go somewhere on the inlet manifolds. Obviously, he's got a separate front-facing intake manifold, so you can just find a relevant place for that. Then the harness carries on down here until it gets to the middle over here, and this is where it's going to break out to quite a large number of different sections, and I'm going to go through all of those now for you. Okay, so what we'll do is I think we'll start from underneath the actual inlet manifold because a lot of them poke through, and then we'll come back up to the top there like that. Okay, so as you can see down here, we've got our 4 plugs that are going to be some of the breakout harnesses down at the bottom here. You'll see some of them are blanked off because obviously there's options that the customer is not stated for now, but obviously we build it into the harness so that he can add stuff on later. Okay, so I'll start with the one right at the front here. This is for the knock sensors. So in this particular case, the customers, we're just going to go with the standard knock sensors that are on the engine harness, but obviously it does unplug. So if the customer wanted to change to Bosch wideband knock sensors, we're more than happy to, if he can phone us up, we can supply both the knock sensors and the studs and nuts and build him another harness to go with that. So obviously we've got twin core shielded cable coming to this plug to allow us to do that. Okay. Next up, we've got our oil. So as you can see in this particular case, we're only using the oil pressure switch currently on there. But again, the customer can upgrade. It is a 6-pin plug. So he has the ability to add, he can actually keep the oil pressure switch, but he can also add on oil pressure and temperature as well. okay? And then next up, let's pull the one from the front here. So I've got gearbox down here. So what we've basically done is we've included the ability for reverse lights, okay, and a Hall effect style speed sensor. So again, 4 pins, we've got 12 volts, we've got reverse, and then we've got the 2 signals, so ground and signal, for a Hall effect speed style sensor if he wants to add that on later as well. And then lastly, we've got our fuel over here, and because we have the ability with the Fury to have 4 temperatures on our fuel pressure, we've got a 4-pin plug, and that allows us to put fuel pressure and temperature on here. Again, something the customer can add on later if he so desires. And then lastly, this little strand you see coming down here, that is your starter solenoid. So that goes onto the starter motor just down there. Don't forget, you've got your big proper power cable for your starter motor, so that goes directly to your battery. Obviously, we don't include that in the harness. That is a separate one altogether. Okay, I'm going to pop back up over here now. So obviously we've got the majority of those all done. So that's an injector harness there. That all goes down there. That all goes down there. And then lastly, off that little section there, we have our throttle plug. So again, everything is labeled. I'm just going to try and see if I can pull it out here. So you can see that is labeled throttle over there. So as discussed, in this particular case, the customer is only actually requiring a TPS plug. So you see a TPS plug and a intake air temperature sensor. Now obviously it's a 12-pin plug. We're only using a very small amount of wires. Built into this plug is the ability to use a complete drive-by-wire throttle as well, okay? So if he wants to change over to like a Bosch drive-by-wire throttle later down the line, more than happy to do so. And this will allow him to do that. So he can just unplug this and we can build him a harness for a drive-by-wire throttle if he wants to change over. Right, so carrying on now, we're going to come down over here. Sorry, the harness is pulled a bit that way, but this would sit more or less in the middle here, this little breakout section over here. Now what we've done is we've incorporated 2 things in here. So one is going to be his oil control valve, because it is a VVT-i, so that needs to go in there. Then we also got his coolant temp sensor. So what we've done is to make it modular and usable on both a GTE and a GE, we've put this breakout here in the middle. You'll see this would normally hang down over here if it's a GTE, because your coolant temp sensors are here. In this particular case, because he's using a 2JZ GE VVT-i, as we know, his coolant temp sensor is underneath the inlet manifold here via the head. So that's why we've made it dangle so it can go either side down there. And in this case, he's going over there. Now we also have put the ability in, which he's not using now, but we have put the ability to use a temperature sensor for a gauge. There's an extra wire in here. We've got a 3-pin plug, 2 for the coolant temp sensor, 1 for a gauge one if he so desires to use that. So again, if you use like a CAN dash, obviously all the data will come from the ECU, but if you wanted to use analog signals for the time being, if you didn't want a CAN dash, we've put that ability in for you there as well. And that also applies to the oil pressure. The oil pressure switch does go to the ECU, and it also goes to one of the client plugs in the fuse box, so you can just use a little LED on your dash if you so desire for that. All right. Coming down further over here, it's then going to break out down at the bottom here on this side, and then we're going to go to our cam sensor over here, and we're going to go to our alternator over here. So again, all of this is controlled via the fuse box, and obviously the crank sensor goes to the ECU. And then lastly, which I've got dangling up here, is his Mac boost valve. So obviously this is designed to mount in the engine bay here near the turbo, so that obviously he can plumb that up as per necessary, and he can control the boost via the ECU with his Mac boost valve. Okay, right, so hopefully that's relatively straightforward for you, Nathan. You can see how everything actually goes onto the engine itself. Obviously in your particular case, you're going to have the different intake, so you're going to run your harness along there on the inside, and then obviously you'll have all your injectors, etc., on their own separate harness there. So again, if you find that your injectors are too small and you want to change them over and you have a different connector on, just give us a shout. We'll build you a new injector harness with whatever injectors you would like to use. Unplug your old one, plug in the new one, and away you go. You don't need to buy a new harness again. So guys, that's the major benefit for these, is basically you can upgrade your project as and when you do it, and you can change things like coils, injectors, throttle bodies, pressure sensors, etc. You don't need to buy a brand new main harness. You just stick with the main harness. You just chop and change out all of these little sub harnesses over here. Okay, so again, hopefully relatively straightforward for you. Now you know where everything goes on the engine. Obviously, I do apologize, I can't show you with the coils on. Unfortunately, we have to stick with this engine because we do get a lot of standard management IS300 and GS300s, and unfortunately, I don't have a JZ GTE in my collection to be able to test. I do apologize, guys. Right, so what we're going to do now is that's the complete layout of the harness. So next thing we're going to do is we're going to be starting it up, and obviously we're going to be testing everything, bearing in mind that we are using the dumb coils and the igniter for the particular case, but it proves the point that everything else is working as it should, and we will check all those signals. Lastly, what I didn't mention as well, which I will actually do in the startup, is the starter relay in this particular harness is controlled via the ECU. Okay, I don't think I've done a video on starter relay control for the link, so I may have to do that for you guys. At this point, we've got another link over there as well coming through, so maybe I'll do it on this one, maybe I'll do it on that one. But basically, what happens is when you provide the start signal, or what we say is the start signal here, with 12 volts from your key, the ECU is getting a signal, and it's going to activate the relay to start crank either for 7 seconds. You can set that up. You can do 7, 5, 10, whatever you want to do. Or if the engine RPM goes above 600 RPM, then it'll cut the relay out. Okay, so there can be no sort of misjudges, accidentally hitting the start button while the engine's running, etc., etc. All controlled via the ECU there for you guys. Okay, right, so complete layout done. Again, now we're going to go and start doing the testing, and we're going to start the engine up, and you're going to hear it run. All right, so let me get that all prepared, and I'll be back in a second with you guys. Cheers. Right, guys, so obviously we did the rest of the video last night, so as you can see, the sun is now out. We are the next morning. I did let the battery go flat. That was my silly fault, and it was already 11 o'clock at night. So now we're going to carry on with the testing of this harness. You'll also notice I've removed the intake so that we can pull each injector out one by one when we test them from the ECU. So first thing I'm going to do is we're going to go through what exactly we are going to test. So there's two sections that will be split into. One section where just the ignition is on, and obviously the engine's not running, because you can see the intake is off. And then we'll have the last section where the engine is actually running. So in terms of what we're going to be testing now with just the ignition on, we're going to be testing the check engine light. So you can see at the moment it is on over there, and it is on the cluster over there as well, busy flashing. Then we're going to test the oil pressure light. So you can see at the moment it is on, the oil pressure light. We do have the oil pressure light also fed to the ECU, so I'll go look at the live data there. And when I disconnect the oil pressure switch, you should see that go from active to off. Coolant temp, what we're going to test is the wire that runs from here to the actual fuse box itself. So remember, in this particular case, we're not actually having a single wire temp sensor connected. So I'm going to disconnect that, ground that wire out, because this little device, as long as it's grounded out, you'll see the temperature gauge on that go down. That just shows me that the wire is connected and it is working. So that's that little test over there. Then what we're going to do is we're going to go through the sensors. So what we're going to basically do is unplug or move the sensors and show the data on the ECU to make sure that everything is working as it should. And then lastly, we're going to go onto the injectors and coils. So luckily with the Link ECU, I can test each individual injector. So I'm going to pull them out one by one as they're testing it, just to show that it is correct and it's connected to the correct place. Once we've done that, then we're obviously going to jump onto firing up the engine. So in terms of the starter, as discussed, this starter is controlled via the Link ECU. So the signal we're going to feed it is just going to tell the ECU to crank the starter relay, which it'll crank for either 7 seconds or until the engine reaches a certain RPM, aka it is actually running. Fuel pump we'll test once everything is back together and it's ready to start. So we're just going to make sure the fuel pump is working and it is controlled by the ECU itself. Coolant temp. Obviously, we are going to have a look on the cluster there and make sure that the coolant temp is reading correctly, as well as obviously the IAT. And then we're going to do the alternator light. So at the moment, you'll see the alternator light is actually on. What I'm looking for is obviously when we start the car that the alternator light turns off. So I can't do that with the ignition on. I'll do that with that one over there. Okay, so first thing I'm going to do, which I didn't do in the previous one, is I'm going to explain all of the connectors. So these are these 2 pages that you see over here. I did briefly go through all of these connectors, but I just want to show you all the paperwork that you're going to get that'll actually explain where everything is connected to and what pin goes to where. So for starters, on your fuse box itself, remember we said we've got the 2 connector plugs that are going into the vehicle. These are the ones you're going to connect to interface with your vehicle. First one is a 9-pin plug. Second one is a 6-pin plug, but we're only using 2 wires, and I think in this case even those aren't really relevant for the time being, but I'll go through those with you now. So pin number 1 of the 9-pin plug, that's going to be a red 14 gauge wire. That is a 12 volts, power 12 volts. Now, I do stipulate in the instructions here that if you are not using drive-by-wire, you can actually connect that to an ignition 12-volt source. If you are using drive-by-wire, you do need to connect it to a permanent 12-volt source. So I would advise just from the beginning to connect it to a permanent 12-volt source, but I will leave that decision up to you guys on your end. Black and yellow, that's a little 20 gauge wire. That is your start signal. Now I have noted in here as well, because the ECU is controlling the start signal, I have run the start signal through a fuse before it goes to the ECU, so there can't be any damage to the ECU. But what you can also do is the ECU is capable of receiving either a 12 volts or a ground. I've set it up for 12 volts because most key barrels work with the 12 volts. But if you're using just a button and you want to switch it over to a ground, it is no problem at all. You can do that. You just need to set the ECU to see the starter signal as going low or a ground rather than going high or receiving 12 volts. So that's absolutely fine. Yellow and green, 10 gauge, that's the one I was talking about earlier. You can see the yellow and green wire is connected to our white box over there. So that's the one we're going to use to test to make sure the wire is connected correctly through the harness. Gray, which is another 16 gauge wire, that is your fuel pump. So again, I've given a good explanation down here, but basically that supplies the 12 volts to run a fuel pump. Obviously it runs through a relay, which is controlled by the ECU. You can either take it directly to a fuel pump if your fuel pump is not going to pull more than say 15 to 20 amps. If you have two fuel pumps or anything like that, then feel free, you can just use the grey wire as a trigger for a relay, which you can then fit by the fuel pumps to run a thicker cable if you need more, because you've got more than one fuel pump. All right, then you've got yellow red, which is the yellow red over here. You can see it's connected over to our cluster over there, which is why our check engine light is working over there. Then you've got yellow, which again is over here and it's connected to our cluster, so that is going to be the rev counter. So it's going to make sure that that wire is connected correctly, and I do go into detail about the TAC connection. Obviously you can set the output on the ECU to match your particular cluster. Just a side note, if you have an older vehicle that had a rev counter that took a signal, say from an igniter or something, 9 out of 10 times, I'm not going to say every time, 9 out of 10 times, you can go to the back of the cluster and there's usually a resistor to turn a high level signal into a low level signal. You can remove that resistor and just bridge it with a piece of wire, and then the signal from your ECU should work on the cluster. Okay, this is coming from a Toyota world. Again, I'm not sure about the other ones, but I'm pretty sure that if your rev counter took a signal from an igniter or something like that, it's a high level signal. If you try and take it directly from the ECU, it's not going to be enough. So again, see if it has that resistor, remove it, and then it should work absolutely fine. Then we've got black with a red tracer. That's this wire over here. You can see I've already got it plugged in. So that is your ignition source. So that is the one from your key barrel, or if you're going to have an on switch, if you will, from an ignition source, that's where it's going to come from. That does have to be 12 volts. And the only caveat, or the only thing to watch out for, is if you are using a key barrel, make sure that you don't use the accessory feed, because what's going to basically happen is when you move the key from on to start, the accessory feed gets its 12 volts cut, which means your ECU and everything is going to turn off when you go to crank, and then obviously nothing is going to happen. So just bear that in mind if you are using a key barrel. Not a problem if you're just using your own switch. Number 8 is pink and blue, so pink with a blue tracer. That's obviously this one over here that I've got connected to the LED. So that is your alternator light. That's connected to the alternator on the engine. It does give off a ground signal, so you can see my little LED is got 12 volts on one side, the pink and blue on the negative side of the LED. Now you can use that in your cluster. You can also just put an LED on your dash with a battery light next to it if that's the way that you want to go. And that will then tell you how that particularly works. If you have an old cluster that uses incandescent bulbs rather than LEDs, what I always advise you to do is one of two options. A, just put a diode in so you don't have any feedback from the cluster into the alternator, which can then feed back to the alternator ignition into the whole system. All right. Number 2, replace the bulb with an LED bulb, because that'll do exactly the same job, because an LED is a light emitting diode, so it'll stop the back feed from the cluster into the system over there. All right. Number 9 is yellow with a black tracer, and that is your oil light. So you can see here I've got it connected to this device so it can output the oil light on the dash there for us, so we can see that. Right, so that's the 9-pin connector. That's pretty much everything you need to get the engine running. Now in this case the harness does have a gearbox sub harness, so what I have done on this little 6-pin connector is I've put the reverse light which is number 1, which is a light green. So you can see a light green over there. And the other one is a blue, and that is a speed signal. What I mean by that is on the gearbox plug, which is just over here, which in our case is obviously blanked off. Now, if you had a gearbox with a 3-wire speed sensor, that signal is going to go from here. It's going to split, go to the ECU and to that wire over there. So if you needed a speed signal for a dash, you can take it from there, but obviously the ECU itself as well will be able to pick up on that signal. The reverse light, well, that's relatively straightforward. So if you connect the 2 wires, the 12 volts and the reverse straight to reverse switch, and you just use that, that's absolutely fine. And then you can use that light green wire that will give you your 12 volts for your reverse light. So obviously in this case we haven't specified a gearbox harness, but if the customer wants to add it on later, you can just give us a call, give us the measurements, and we can make him a harness for a reverse light and a speed sensor, provided that's the case. Obviously examples like a BMW gearbox, you don't have a speed signal on the gearbox, so hence the reason why we did split it up like that, so you can use whatever gearbox you want and get whatever signals are applicable to that particular gearbox. Right, so moving on to the auxiliary connectors. Now, obviously with every single harness, you'll see here you get a complete pinout of the ECU. All right, so everything is labeled as part of the welcome pack that you get. Now, in these particular plugs over here, again, part of your welcome pack, I've labeled what exactly each one does. So we try to name it as good as best we can. So obviously you've got analog, you've got CAN, you've got auxiliary, you've got dig for digital, and you've got pedal, PDL for pedal. All right. So the auxiliary one is just any unused auxiliary output. So in this case, it's auxiliary 8, injector 7, and injector 8, because again, we only got 6 injectors on this one. The ANA or analog connector, that's going to have pin 1 is 5 volts, 2 is sensor ground, 3 is analog 8, and 4 is analog 9. So that's if you want to add more sensors on that are not already in the system here. You've got your 5 volts, you've got your sensor ground, and you've got the 2 analog inputs that you can use there. Digital, that's just the digital inputs that are unused, so digital 5, 6, 7, and 8. So that's what's available on that plug over there. So again, if you want to add switches for certain things, just put them straight into there. CAN connector, obviously the CAN is exactly how Link wire their CAN. So pin 1 is 12 volts, pin 2 is ground, 3 is CAN H, and 4 is CAN L. So this plug is enough to supply both the power and the ground for, let's say, a dash, or any other CAN related device that you wanted to use. You've got 12 volts, you've got ground, and you've got the CAN wires there as well. Last one is your pedal. So what we've basically done in this particular case is, because a JZ can have various different throttle setups, in this particular case, if you look at a 2JZ GE VVT-i, you've got the throttle over here, you've got your TPS over there, you've got your pedal position sensor over there, and then you have your drive-by-wire over here, which also includes a clutch as well, okay? So in this particular 12-pin plug, we've got the ability to run this throttle, or a 1JZ GT VVT-i, or a 2JZ GT VVT-i, because they all run the same system. Now then, a lot of people change over to, let's say, a Bosch, for instance, and that just has your 6 wires, which is your 4 TPS wires, 5 volts, TPS signal 1, TPS signal 2, and signal ground, and then you have your positive and negative for your drive-by-wire throttle. So what we've done is, in this case, we have taken and made a pedal plug. So what we've done is, that pedal plug over there shares its analog input between here and there. So if you use a Bosch one, we just wire up the 6 wires for there. If you were to use a 1JZ GT VVT-i or a 2JZ GT VVT-i, all the pedal wires and the TPS and the throttle motor would all be coming to here, and that pedal plug would not be used. On the other hand, if you wanted to use this throttle, but you didn't want to use this accelerator position sensor because maybe it's broken, you can then just fit an electronic pedal in your car, and you can use this pedal plug over here, and then we just wouldn't add it into this harness section over there, okay? I know it sounds really complicated, and I do apologize, but it's basically to cover all of your bases, and so you guys can do whatever you want. Again, the main aim is to not have to buy another harness, merely just change these sub harnesses out to suit your particular application. Okay, so hopefully that makes sense, but basically you can run any type of throttle you want, whether it be the standard ones, whether it be a Bosch, anything you like, and you can even fit a pedal on the inside of the vehicle, even if you're using one of these throttles, all incorporated there for you. So you do have to bear in mind that if you, in this case for this particular customer, he's not using a drive-by-wire pedal, so theoretically he's got 2 analog inputs here that he could use, well actually 3, because we've got TPS signal 2. which he's not going to be using. But we also have those same signals here. So if you're trying to use the signals here, which is basically if you go to the pedal connector analog 3 and analog 4, so analog 3 and analog 4 go here and here, so you can't use them on both, if that makes sense. Okay, so if you use them here, you can't use them there. If you use them there, you can't use them there. All right, so hopefully that makes a lot of sense. Again, it's all in the paperwork there for you guys, so don't stress too much about that. Okay, right, so those are all the plugs that are there. Sorry, I didn't go through as part of the layout. I knew it would be a long, drawn out section, so I left it for the testing part there, and it would make more sense when we do the testing from there. All right, so first thing we're going to do is jump into the testing of the items with just the ignition on. I've already got the ignition on there for you. What I might do is I'll pull it off and put it back on again so you can see the sweep of the RPM of the dash. That'll also help me do the tacho signal feed at a little test as well. So I'll pull that off there. You'll see check engine light has gone off. Remember that the ECU does default to ground, so because I'm supplying an alternative power source to this dash, you can see the check engine light goes on dimly. But as soon as I connect up the ignition again, you'll see the RPM does a sweep of the dash there. Our check engine light comes on and on the dash as well, so I know that all the wires are working as they should. So check engine light we know works 100%. What we're going to do now is move over to the oil pressure switch. So all I'm going to do, because at the moment it does have a ground, I'm literally just going to pull this off. And what you're going to notice is as soon as I do, you're going to see the oil light on our dash goes off. You can see there it's on, there it's off. All right, and obviously it's on the ECU as well. So what I'm going to do is try and lean over here, and I don't even know if you're going to see it. It's very, very dark, but you can see oil pressure switch is second from the top on the digital there, and you can see that goes off. Hopefully you can see that flash of green light, so that goes off when I pull it off and on when I put it on. So both the ECU and the wire over there know what's going on with the oil pressure switch. All right, coolant temp, nice and simple. I'm just going to disconnect my coolant temp sub harness over here. Okay. Right, so that's the coolant temp sub harness over there. I'm just going to grab myself a wire, put it in for the gauge temp wire, which is number 3. Slot that in over there. And then all I'm going to do is ground it out. And as soon as I ground it out, you're going to see that on my cluster, our temp gauge starts coming down from full hot to 0. So as I ground it out there, right, and as I let go, you'll see it shoots up. Right, so I'm super happy with that. I know that wire is connected correctly and it's going to the right place. Okay, so I'll just plug that back in over there. All right, we're going to get some error codes because I'm unplugging everything as we go along, so that's just be careful if you see error codes on there, just because I'm unplugging everything. Right, so moving on to the sensors, what we're going to do is make sure all the sensors are working correctly as they should. So what I'm going to do is I am going to pull up all of the data here so you can see really nicely and make it a bit bigger. So you can see we've got coolant temp, we've got IAT, okay. So what I'm going to do now is I am going to pull the coolant temp sensor plug apart again, and as soon as I do that, you should see that the coolant temp will default. There you go, down to 0. Put the coolant temp back in again, so we know that that is in the correct place. What I'm going to do now is I'm going to disconnect the IAT as well. You'll see the IAT is now on 25, down to 0, plug it back in again, back up to 24. So I know that that is connected correctly and into the correct place. All right, you can see our TPS is on 4.4%. Now obviously this is a drive-by-wire throttle, so it does slightly hold the throttle open as part of that. So what I'm going to do now is I'm just going to put my finger in here. I'm going to push it completely closed. Goes back down to nearly 0. And then I'm going to push the other side, and you'll see it goes all the way up to, well, 100% if I give it a little bit more of a push. Now, close enough. There you go. All right, so I know that that works 100%, so I know the TPS is connected correctly and it's reading exactly as it should do. Do remember you should always do a TPS calibration on your throttle because they can have different locks and stops and so on and so forth. So every time on your engine, you should do a TPS calibration to make sure it is absolutely correct. Hold it fully closed, hold it fully open, do the calibration, everything is sweet. All right, so what other sensors have we got? Right, so we've done coolant temp, we've done IAT. Wideband we'll see when the engine is running, so that's absolutely fine. Map sensor, okay, so what I'm going to do is, let me open up a new view. Let's have a digital gauge. And we'll do map. And what I'm going to do is I'm going to try and blow it in there. So let me just quickly make sure that it is calibrated. Yes. Okay. Right, okay, anyway, I'm just going to test that it works now. So I'm just going to grab my map sensor, I'm going to grab my little vacuum hose. And what we're looking for basically is for it to go up and down as I blow on it. There you go. Fantastic, okay. So again, as with the TPS, just do a map calibration and make sure that your map is set up correctly on your ECU before you start to use it. Right, okay, so that's all of the sensors that I can test on the actual engine itself. Now I'm going to move over to injectors and coils. So again, we're going to use the ECU to do that test. I'm going to get my helper Nicholas to come help me now. And he's going to basically test all the injectors on the actual software itself. I'm going to unplug them as he tests them to show that it's working. 1 is 1, 2 is 2, 3 is 3, etc, etc. All right. So Nicholas, if you can test number 1, so you can see I've got injector 1 over there. And if you test number 1, so you can hear it clicking. There you go. Right, move over to number 2. So again, injector 2, you can hear it clicking, and as I lift it off, there you go. Right, let's move over to number 3, so you can see injector 3. As I lift it off, it goes quiet, comes back on again. Let's go to injector 4, and as I lift it off, you can see it goes quiet. Injector 5, and as I lift it off, it goes quiet. And lastly, we're going to do injector 6. As I lift it off, it goes quiet. Fantastic, super happy with that. Injectors are wired correctly and to each correct injector. Right, now we're going to test the ignition. Now, unfortunately, you guys are going to have to take my word for it. We're going to put the camera as close as I can, but you should hear the coils firing. So first of all, this is going to be coil number 1 at the back. So if you test number 1, Nicholas, you can actually hear better there. So that's number 1 going off. Okay, so stop number 1, and then we'll go to number 2. Oh, sorry, this is number 2 here. Yeah, where's number 2? Oh, number 2 is at the front here. Right, hit number 2. Hopefully you can hear the actual spark plugs firing. And let's go to the middle one, which is number 3. So let's do that. And then you can hear the change of note as it's moved over to number 3 over there. Fantastic. All right, so those are all the tests we're going to carry out with just the ignition on. I'm going to jump off now. We're going to put all the inlet manifold back on, take all these injectors away, and then the next step is we're going to fire it up and test everything else. So bear with me a second while we do that, and we'll be back. Right, so we're back now. Everything is all on. We are ready to start the engine. It's going to be a short little test. Obviously, we've tested the majority of the stuff already without the engine running. So first of all, starter. What are we testing? We're testing to make sure the whole starter circuit works exactly as it should. So again, you're going to see I'm only going to literally just touch the 12 volts on the black with a yellow tracer wire. The ECU will then take over, activate the relay until the engine fires up. Okay. Then what we're going to do is fuel pump. Actually, when I put the ignition on, you're going to hear the fuel pump running. Obviously, when the engine's running and it continues to run, you know that the fuel pump is working exactly as it should do. Tack, we should get a tacho signal coming through the dash when we fire it up, so that should be good. And then coolant temp, we can just check over there. So at the moment you can see it's about 26 degrees. Hopefully after we run it for a bit, you'll see that it'll climb up, but we know that it's connected correctly already. And the alternator light, when I fire it up, hopefully that LED is going to go off, so I have tested it already. And that's going to show us that the alternator is charging as well. I do have a battery charger on here, so what I'll probably do is just remove this for now. And we should be able to see the voltage on the dash, so that should hopefully go up when it is running. Right, so first thing I'm going to do is ear protection, because I'm old and my ears are not as good as they used to be. So first of all, we're going to put the ignition on. So I'm just going to, sorry, I can't do this single-handedly, so bear with me. All right, so hopefully you heard the fuel pump run there. But anyway, we're going to do it as part of the test. You can see that we've got fuel pressure on our fuel pulsation damper. The screw has risen up over there. Now to start it, nice and simple, you're just going to see, I'm just going to touch this on 12 volts and it's going to start on its own. So 1, 2, 3. You can see the LED has gone off for the alternator light, so that is all good. You can see we've got a tacho signal coming through over there, so that is all good. Right, so she runs, she's sweet, everything is good. You'll see the lambda values are quite conservative. It is a sort of a startup map, if you will. So again, don't be too stressed about it. We don't want to run it lean, obviously, when it's running. But Nathan, obviously, when you have it all plugged in, get your lambda in, and then you can activate closed loop control just to fine tune it a little bit more if you want to. But again, the emphasis is getting it up and running, making sure you have no leaks, so you're not wasting your dyno tuner's time, and that you are ready to go to the dyno to get it set up from there. Now, I do a video about first startups, and I think I did use a link. I'm 100% sure I did use a link on that one, so I'll put a link to that in the corner over there for you, so you can go through the process over there. In case you're doing your own one and you're trying to see what it is, you'll see how actually easy and simple it is to get an engine running and the steps that you would normally go through to do that. So again, hopefully that's been helpful for you, Nathan. Hopefully when you get it to you, everything is going to be straightforward and easy to fit in and get fitted. Just remember, in the future, if you do decide to change anything, whether it be injectors, coils, whether you want to add oil pressure sensors or whatever, just give us a shout. We can supply you everything we need, and we can usually get it done within a couple of days, get it out in the post to you, and you can just plug it straight into your engine and off you go. And we'll talk you through either on TeamViewer how to set up your ECU to add those extra sensors in that are already pre-wired for you there. All right, so for everybody else, thanks for watching. If you guys have any questions, please let us know. If you have any comments, things you'd like to share, anything that you've seen as part of the modular harness you think's a good idea, bad idea, is there something else you'd like to see built into the system over there? Referring back to earlier, would you be interested in us doing this where we can actually use still the extended igniter if you guys want to use your dumb coils with a Link ECU or a Haltech while you're busy upgrading all your bits and bobs? These are all things that we can do, but you guys let us know what you want and we will get it done for you. But thanks for watching, guys, and we'll see you again soon. All right, bye-bye.